Okay, so here we're going to just go through number one and take the derivatives. The first thing that's really important to note here is going to be that this says do not simplify. So all it's asking you to do is take the derivative. Okay? So when we go to do this for part A, and we go to take the first derivative, it's really important to notice what rules we're going to use. Right? And right now in green and red, I can see that I'm looking at a product. So I'm looking at a product where we have one function times another function. So this cubic function times sine x. And then when I look at the cubic function, I notice that there's a chain rule that's going to be applied. There's this outer function of something cubed, and then an inner function where that something is x to the 4 plus 2. So when we go to take this derivative, it's going to be equal to the first times the derivative of the second, and then it's going to be plus the second, which would be sine x, times the derivative of the first. Okay, and so here I'm going to go, the outside function is something cubed, so my derivative of that will be 3 times something squared. And then when I put in the something, keeping it exactly the same as this, and then I'm multiplying by the derivative of the inside function, which in this case would be 4x cubed, because the derivative of the 2 is just 0. Okay? And at that point, I've taken the derivative of that first function. Okay? And I don't have to do any simplification, so I'll leave it like that. In B, okay, we're looking to find the derivative of dy by dx. And we have a quotient, so we can use the quotient rule. And it's also worth noting that the derivative of the top is, we're going to need to use the chain rule, right? So the derivative of this top, we need to use the chain rule. And so you may want to just do something like f of x is equal to tan 3x, and then show the derivative of that separately, okay? Which would be the derivative of the outside, secant squared, keep the inside the same, 3x, times the derivative of the inside, which would be 3. So the derivative of tan of 3x would be 3 secant squared of 3x. Okay. And so we can just do that sort of as an aside, so that when we go to do our actual derivative, we can just write it right in. So now we're going to go bottom, 2x times derivative of the top. We've found that over here, so that's going to just be 3 secant squared 3x minus top tan 3x times the derivative of the bottom, which is just going to be 2, all over the bottom squared, which in this case will be 4x squared. Okay. So that's the derivative of B. The derivative of C, one of the things that might be useful to do here is just to rewrite this as x to the 5 plus 2x to the minus 1. And then when you go to take the derivative of this, and we're going to show that by dy dx, we can just apply the power rule twice. So we're going to get 5x to the 4 minus 2x to the negative 2. And again, it says don't simplify, so we don't need to write that as a positive exponent. So we're done here. And then our very last one, again, I might want to rewrite this. I'm going to need to use the chain rule, but I'm going to write it as x squared plus 1, where the exponent is to the half. And then what I have is something to the exponent of the half, and then x squared plus 1 inside. So when I go to take the derivative, I'm going to get the derivative of the outside, 1/2, keep the inside the same, to the negative 1/2. Okay, in this case, the inside is x squared plus 1, and then times the derivative of the inside, which will just be 2x. Okay, so that is number 1.